Now, for the last 3 episodes, we've been talking about chemistry. The first episode, we've been talking about chemistry and the periodic table, and the second and third, we've been naming these 80 elements. And that's what makes them precious. And today, we'll be going for the last batch of elements. Lesson 40. And this is gonna be good. And let's get started! Da-da-da-da-da-da-da. Now, first of all, Thallium, number 81, and looks like these little weird tentacle arms. Lead, Pb, from plumbing. Pb is the symbol for the Latin word and Greek word plumbing, and that's where the word plumbing for English comes in. And it is used in this lead crystal glass, and it is very poisonous. So if you accidentally get lead inside your stomach, you're dead in a few seconds. Bismuth is what is inside this colorful rock, and it is pretty messy. I am pretty bad at drawing colorful rocks. Polonium is very radioactive. Boom, 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 boom. Astatine is this rock, very smooth rock. Radon is inside the lava, the flowing lava, not the that bursts out the volcano. And francium only lasts a little time, and it's inside the sorite. Sorite, that's what the rock is called. And the radium is used to make atomic clocks. Radium's energy radium's energy moves every 1 per second, exactly 1 per second. So that's why we make atomic clocks, and that's why atomic clocks are the most fatal clocks in the world and the most accurate clock in the world. Actinium, and this is what actinium looks like, and that's how the actinides got its name. Thorium, from the god Thor. Boom, 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 boom. And not the Marvel Comics Thor, alright? I drew him. Protactinium, which is the light coming out of these rods. Uranium, which is the deadliest compound in the world. And stop for a minute. Now, all the elements until 92, which is uranium, a chemistry lesson here, uranium, on every element until uranium can only exist in nature. The others from 93 to 118 elements that we found clearly, it can only be made in a lab because it is so unstable that if it is found in nature, it would literally explode our planet. And we might be dead already if it's like that. So yeah, that's exactly what happens. Now on to the next chemistry lesson. Boop! And stop. Neptunium, and this element is named after Neptune. Plutonium, and this is the same thing that is inside the uranite, and it's named after Pluto. Americium is named after the Americium. It is named after America. Dun 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 dun. Curium. This element is named after Marie Curie. Berkelium. It is named after the Berkelium lab, which is where the atomic bomb was made. Californium. It is named after California, and this is what Californium looks like. Einsteinium, and this is named after the most obvious people in the world. Albert Einstein! And it's E equals MC squared. Fermium, named after Enrico Fermi. Looks a little cartoony, right? Mendeleev, the periodic table man. He was the guy who invented the whole periodic table. Dmitri Mendeleev. Nobelium, Alfred Nobel, who discovered dynamite. It's last night. Watch me breathe the fire, set night light. No, not that dynamite. Not the BTS song Dynamite, right? Dynamite, the bomb dynamite. Now Lawrencium, named after the guy who was in charge of the Berkeley lab, Ernest Lawrence. Rock and roll. No, stop it. King Kong. Rutherfordium, named after Ernest Rutherford. Now this is what his photograph looks like, and this is the camera that made that photograph. Cool, huh? Dubnian, named after Albert Dubnian, discovered by Albert Gihoso. Seaborgium. This machine made seaborgium and 4 other elements. And that element was discovered by Glenty Seaborg. That's where seaborgium comes in. Bohrium, almost to the end. Bohrium. It is named after Niels Bohr, a very, very cartoony person. Hassium, a transition metal, and this is what created hassium. This machine is what created hassium. And that machine is so complicated to draw, which is very hard to draw, so that I have to put it really, really small. And then here's Meitnerium, and it is named after a girl named Lisa Meitner, and she is the one who pressed the new element discovered, NED, discovering light comfort. New element discovered, and they decided to call it Meitnerium. And that is not true. I made the light up. From Stadium, and which sounds like Darth Vader from Star Wars. Pew, pew, pew. Roentgenium, and it is named after Wilhelm Röntgen, and it is, the equation that I just put in. Copernicum, named after Nicholas Copernicus. The statue looks a lot like him, huh? Very hard to draw. What's very hard to draw? Yeah. Nihonium. Nihon is Japanese, and that's why I drew Japan. Flerovium is named after Georgy Flerov. Looks very much like him, huh? He's bald, only with a few strands of white hair. Moscovium, named after the Russian city, the old Russian capital named Moscow. And this is what it looks like. Livermorium, and this place is where Livermorium is discovered and named after. Yes, that's exactly where it is. Tennessine. When Tennessine is just made, after 10 seconds or less, it just disappears. And that's why we don't know what it is used for. Og²², the last element, named after Yuri Og²². Now, I want to tell you one chemistry lesson here. Now, Dmitry Mendeleev here, whoa, in every book is the guy who discovered the elements. However, one person decided that there should be an end to Dmitry Mendeleev's periodic table of elements. Now, back then elements were discovered by the atomic weights, and he thought that somebody thought that the element 72, or somewhere near it, was where the periodic table will end because of all of his equations, some complicated equations, and it has to stop. It has to have atoms going faster than the speed of light. But however, he was proved wrong. We were able to make it all the way to 118 and probably more. And then a few years later, a century ago, another man thought that there should be an end to the periodic table. An element that still does not exist. Even today, it doesn't exist. And it is element 227 or 5 or between the, well, it is an element 220 and something, but I'm pretty sure it's 227. Well, first of all, here's the reason. Now, this is methane. This is methane, right? This methane. This is a methane compound. However, we're going to use this to explain an atom. Let's say that the middle carbon ball is the nucleus with the proton and neutrons. Now, the more protons and neutrons you add to the nucleus, the more electrons you have to put around the nucleus, and then you have to spin them even faster, so that the neutrons and protons won't break apart. And then by 227, the elements after 227 will have the atoms and will have the electrons that are spinning so fast that they are faster than the speed of light. And anything faster than the speed of light is impossible. But by now we have found the 118 elements, so we're pretty close. And yeah, if we do ever find more elements like element 300, then that might be the best thing that might happen to American history. Human history, and I hope you might be the one who discovers it. Now, this is basically it. I hope you enjoyed this episode as much as I did. Please like, share, and subscribe to the channel if you haven't already, and I'll see you in the next episode. Shinhan out. Peace! The end of Chemistry Sean.